अच्छा remember कि comparison था कि you had alcohols which were like really bad acids. They had the weaker ionization. Phenols था, ठीक है, which are not alcohols, ठीक है, it's OH with a benzene. They were slightly better acids, और फिर carboxylic. They were all basically weak acids. लेकिन strongest ionization is for carboxylic acid, and the weakest is for alcohols. और reactions में था कि carboxylic acids would undergo all typical acid reactions. They would react with sodium. ठीक है, they would react with sodium and produce hydrogen gas and a salt. They would react with NaOH, which is a strong base, and they would produce salt and water. And they would also react with sodium carbonate, which is a weak base, and they would produce salt, water, and carbon dioxide. In all these cases, they're going to lose their H plus one ions. ठीक है, every time they're going to lose their H, they like to lose their H plus one ions. अच्छा, phenols का क्या था? Phenols was slightly weaker acids. So they would, अच्छा, phenols जो थे, they would form salt with sodium metal. With strong base like NaOH, they would form salt and water, but they would not react with carbonates. ठीक है, उसके साथ they didn't have any reaction. They would not lose their H plus one ions. Or finally, you had your alcohols. ठीक है, alcohols का था कि they mostly don't lose their H plus one ions. They only lose it with Na. So starting with the first one, ठीक है, कि why are alcohols the weakest acids? ठीक है, तो alcohols as acids discuss कर लेते हैं. So alcohols, ठीक है, starting with this one. अच्छा, we are discussing the acid behavior. अच्छा, alcohols is कि you've got an alcohol, its ionization is even weaker than, but it's got an OH, and an alcohol normally ionizes even less than, but it will form CH3CH2O minus 1, and it will produce an H plus one ion. ठीक है, this is what an alcohol is doing. अच्छा, अब ये कि you've got an alcohol and वो भी लिख लेते हैं, it's got ionization is even less than water. अच्छा, water when it ionized, it would produce 1 times 10 power minus 7 mole per dm cube, which was very few ions. Alcohol's even less than that. ठीक है. अच्छा, so the first question is कि मतलब ये भी ऐड कर लूं जो ऊपर लिखा हुआ है, which is कि they only react with very reactive group 1 metals. That is it. अच्छा, so the question is why do they ionize so less? अच्छा, remember कि every time the explanation would be something similar to this. कि the alkyl chain has an electron donating effect. It's going to push electron density. And because of that, the electron density on the oxygen minus 1 ion, it increases. The oxygen over here already has lone pairs. It already has a negative charge because the H plus 1 left, leaving its electrons behind. So this oxygen already has a negative charge, and there's this alkyl chain that's pushing electrons onto the oxygen. So what happens to the negative charge? The negative charge increases. So if the negative charge is higher, what will it do? It will attract the H plus 1 back. It will not let go of the H plus 1 ion. ठीक है, so that's why there's going to be weak ionization because the H+1 is going to be very strongly attracted to this very high negative charge density oxide. ठीक है, ये clear है बिनल, इसाक, इब्राहिम?
Yes.
क्लियर है कि नहीं क्लियर है?
Yes.
ठीक है, मेरी आवाज तो लैग नहीं कर रही। इब्राहिम क्लियर है? इसाक, इज दिस क्लियर?
Yes, sir.
Yes.
Okay, so your alkyl chain, this is what you're going to write, has an electron donating effect. Hence, the negative charge density on this ion, which is CH3, CH2, O -1, increases, making it unstable. And that will lead to more attraction between the O and H. Hence, the OH bond strength increases. Because they're going to attract each other, strength increases, which leads to less ionization. So it is highly unlikely that it just doesn't want to let go of that H+1 ion. Okay, so that's your explanation for alcohols being terrible acids, right? So they don't like to donate protons. That's the next one. We are going to come to phenols. So phenols were that and their acid behavior. So these are stronger than alcohols but weaker than. But weaker than carboxylic acids. So phenols will react with according to the table that we did, phenols react with what? They react with sodium, and they also react with NaOH, which are strong bases or alkalis, but not with weak bases. Like Na2, CO3. Okay, so what's the reason? Why are phenols slightly better acids compared to alcohols? So the thing with phenol is that they basically have a benzene ring. That's an E signal. Let me reconnect. Okay. I said this one back to phenols. So phenols have OH, and they're also going to ionize. ये screen नजर आ रही है? Minal, can you see the screen?
Yes.
So they're also going to ionize, and they will produce an H plus line. And there's so remember, they're all weak acids, so you always use a reversible sign. It's a reversible. It's going to be a reversible reaction. So why does this phenol, which is I mean, this one is the phenoxide ion. Why does it let go of its electron? So there's a negative charge, but this negative charge over here is not very strong. And the reason is this negative charge, the lone pair, the electrons, they overlap with benzene's pi electron cloud, so they're not there. So the negative charge over here, it kind of spreads out. So the negative charge density decreases. So it's not going to attract the H plus one that strongly. ये clear है? Ibrahim, Isaac, Minal, is this clear?
Yes, sir.
So words में, how would you describe it? It's so what you're going to state is that uh, that the lone pair on oxygen and phenol overlaps with benzene's pi electron cloud. And because of that, hence the phenoxide ion becomes stable. Phenoxide is C6. It becomes stable. And has a lower charge density. And you have a weaker OH bond. There's going to be less attraction between the O minus one and H plus one, so weaker OH bond. Hence more ionization. So that's what that's all about phenols. Uh, the last one is carboxylic acids. Well, carboxylic acids are like complete acids. Carboxylic acids will always ionize, although weakly, but they're obviously better than. ये phenols वाला clear है? Is that clear?
Yes, sir.
Yes.
अच्छा, carboxylic acids are like उनका acid behavior क्या है कि they're relatively the strongest. So relatively speaking, they are uh, the strongest of the acids, or so strongest organic acids, and they undergo all acid. As they undergo all acid reactions. For example, so whether it's a reactive metal, a strong base, or a weak base, even ammonia, they will react. They're going to react with everyone. I say, so what's the reason for that? So if I have a carboxylic acid, for example, I've got CH3, C double bond O and O minus 1, OH, ethanoic acid. This ethanoic acid will ionize, and when it ionizes, it produces the ethanoate ion. So you're going to have a double bond O and an O minus 1, and you're going to have H plus 1. So why does it ionize? Okay, it's all about the negative charge. I say in this case, what happens is that the C double bond O group, ye wala, I mean, this C double bond O group has a very strong electron withdrawing effect. Okay, this group over here is going to try and pull the electron towards itself. So the negative charge density decreases by a huge margin. Basically, at the end of the day, what happens is that the electrons the negative charge kind of gets distributed between the two oxygen atoms. Okay, so the negative charge is like all over the place. You clear about why the negative charge decreases so much that it no longer attracts the H plus 1. Is this thing clear? Ibrahim clear? Minil clear? Isaac, is this clear?
Yes.
Yes, sir.
तो इसके अंदर जो रीजन आप लिखोगे ना so it has a very low, relatively speaking, very low. So the explanation that you're going to write is that oxygen in C double bond O is one of the most electronegative atoms. Okay, so it has a strong electron withdrawing effect. And your ion becomes very stable. Why? Due to lower negative charge density. And the O and H bond becomes very weak and hence more dissociation. Yeah, and hence very weak and hence. Is this clear?
Yes, sir.
ठीक है. Middle clear है? Isaac, is this clear?
Yes.
Yes.
Okay, so So it's all about electron. So basically, the summary is like if I sum this up, I mean, I'm gonna highlight these things first. That this is a typical uh, answer to a question of a very typical question. So this one is, I mean, they're going to ask pretty much the same stuff. And this one. You know. So the summary is, remember the acid stuff is it's all revolving around the OH. It's everything is revolving around OH. Whether it's carboxylic acid, phenol, it's the OH that's losing the H. Now, if I want to summarize everything, it's so summary is you got an electron donating effect. That means weak acid. And you got an electron withdrawing effect, then that means strong acid. Okay, that's all there is. Okay, the more electrons are getting withdrawn, the lesser the negative charge, the weaker the attraction for H plus ion, the higher the dissociation, right? So that's the summary. So we're gonna do variations within these groups now. So variation in acid strength. Let's say within alcohols. बल्कि alcohols का वो पूछेंगे नहीं वैसे. So within, let's start with carboxylic acids. That's the first thing. I've got ethanoic acid, I've got propanoic acid. This is ethanoic acid and this is propanoic acid. Now, which one is going to be a stronger acid? The first one has a shorter, smaller alkyl chain. So it's got an electron rating effect. The other one is, it's got a bigger alkyl chain. So it's got an even, I'm going to write -1 and H plus 1 just to show you that they want to dissociate. Although it's not ionic, but after dissociation, they do become ions. So anyways, um, a bigger alkyl chain has more electron donating effect. ये clear है बात? Ibrahim, clear है? Sark, is this clear?
Yes.
So the bigger the alkyl chain, it's got more electron rating effect. So your RCO -1 ion gets a bigger negative charge. And if it's has got a higher charge density, more negative charge, uh, and it becomes unstable. because it's got a higher negative charge, it will attract the H+1 very strongly. So hence, less dissociation or ionization. Okay, so is this clear that bigger alkyl chains would mean weaker acids? Is that clear?
Yes.
So that would mean weaker acids. Or and then there's going to be more variations. So you can have, say, the yoga bigger alkyl chains. That's similarly, you have presence of Cl. Just hold on 1 second. As a presence of Cl. Okay, that's an electron withdrawing group. So what is that going to do? Well, I've got etheric acid. अच्छा ये वाला फिर next class पे करते हैं. And I've got पूरा लिख लेते हैं. So this is CH3, and you've got a difference is that the Cl has an electron withdrawing effect. Both of them have exactly the same carbon chain, but this one has electron withdrawing effect. तो चलिए ठीक है, ये we'll continue with the Cl thing, ठीक है, tomorrow. ये बाकी clear है बेनल? Ishaq, Ibrahim, is this clear?
Yes, sir.
Yes.
Yes.
चल ठीक है, कल कंटिन्यू करते हैं, ठीक है. ओके,
Okay.
ठीक है.
Good luck.